So we're going to go over them real quick, and we're going to make these fancy little charts that I have designed for you. And by designed, I mean my teacher taught them to me, so I'm going to teach them to you guys. So we're talking about blood types, right? Blood is blood, but we're talking about blood types. What are we specifically talking about? We are talking about little proteins on the outside of the blood, right? Of the red blood cells specifically. And these little proteins are called antibodies. So we have antibodies, and then I'm sure you guys also know we have antigens, right? Or we've talked about antigens, I should say. So what's the difference between an antibody and an antigen? So the way I like to think about it is an antibody is a protein that is on a cell that belongs to my body. So my antibodies belong in my body. My body's not going to attack them. It's not going to think that they're foreign, because otherwise it would be attacking me, and that's a whole different ball of wax that we won't go into. So antibodies belong to me. So they're like little markers. So they're markers that belong in my body, and then antigens are markers that do not belong in my body, they are foreign. So if my antibodies see an antigen that is not compatible, like a blood type that's not compatible, so if I'm like A blood type and someone gives me a B blood type transfusion, the B has different antigens that don't match my antibodies. So my body, my system, is going to say, oh my gosh, there is something going to eat us from the inside out. And when it's in reality it's just blood, but your body doesn't know that. It just knows that it's foreign and it's got to go. So it's going to try to destroy that blood, and in the process it's going to coagulate your blood and you're going to die. So that's not cool. So we want to give the proper blood transfusion when we give blood transfusions. So we have to match the antibodies and the antigens so that blood doesn't coagulate inside the body and so that the patient lives. So I have 4 types of antibodies, right? 4 blood types, basically. So my blood types are A, B, and AB, and then O. So what does that actually mean, though? So when we're talking about the letter refers to what antibody is on your cells. So a person with A blood has the A antibody on their cells. So your body recognizes it as A blood. It's kind of like an ID card. So like I have a driver's license. So the driver's license has the state of Florida written on it, right? So if I were to present my license to a police officer in the state of Florida, he would know, okay, you belong here. You're a citizen of this state. Now, if I went to Georgia and I presented my license to an officer in Georgia, then the officer in Georgia would say, you do not match the citizens of this state. You're foreign. Now, they won't, it's not as serious as the blood typing. They don't, my blood does not instantly coagulate if I get pulled over in Georgia. But it's kind of the same thing. So it's like they have it's like these little cells have licenses that have A written on them. So they are friends with anyone else with an A, and then B are friends with anyone else with a B. So it's how we identify the cells. So I'm gonna draw a little A antigen as a little goalpost, little guy. And I put 2 up here, and you might know why I have 2, but for now, we'll just stick with 1. So AB means that the blood cell has A and B. It has both, which is possible. And then O means it has none. So it doesn't have any antigens or antibodies. So it doesn't have any antibodies. Doesn't have A, B. So it's hanging out by itself. Alright, so now we have A, right? So who can, if a person with A blood needs a blood transfusion, who can they get a blood transfusion from? So you can always get a blood transfusion from someone of your own blood type, i.e. you can always get a blood transfusion from yourself. So you can always get a blood transfusion from A. But could you get a blood transfusion from someone with AB blood? And the answer is no, because AB blood, yes, it has the A antigen, but it also has the B antigen. So my A antibodies are going to see that B antigen that does not belong in my body, and it's going to try to destroy it. Even though it has the A antigen on it, and I have the A antibody, it's still going to try, my body's still going to try and destroy the B antigen on the foreign blood. So no AB. So it can receive from A, but there's one other that it can receive from, and it can receive from O, because O doesn't have anything for my body to react with. So I can receive from O, which is cool. So say I have B blood, and I need blood transfusion. Who can I receive from? It's kind of the same thing with A, just with B. So I can receive from myself, and I can receive from O, because O blood is very nice, it shares, it's very friendly. And then AB blood, who can I receive from? Well, I can receive from myself, and I can receive from O. We already know that, because O can give to pretty much, O doesn't have any antigens, so it can give to pretty much everyone. So I can also receive from A, and I can receive from B, because if I put A blood into a person with AB blood, the person with AB blood, their body recognizes the A antigens. It doesn't matter that there's no B antigen on the blood. They just recognize the A and they say, you can stay, you belong here. Because your body doesn't want to destroy itself. So if it has no way of distinguishing its fighting power to say, you only kill those foreign cells. It doesn't do that, because it doesn't recognize them as foreign, because it recognizes the A antigen alone. It just recognizes the A antigen. So AB blood will recognize A and B, or a combination of both. So AB blood can get from A, and it can also get from B, which is really convenient. So if you have AB blood and you start hemorrhaging, you're pretty set. But if you have O blood, who can donate to you? And the answer is only yourself. So you can only get O blood, because you will react to A and B antigens, because you don't have any. So O can only donate to O. So, but we don't just have A and B antigens, right? It's got to be more complicated than that. We've got to have something else in our body. So we've got this little factor, right? It's another antibody, and it's called the Rh factor. And it's just another antigen, or another antibody. An antigen and antibody are just, you name something an antibody based on whether or not it's inside of you. So if this may help or this may confuse. If this helps, then great. If it doesn't, then don't worry about it. So my blood has my antibodies, and someone else's, and like Melissa's blood has antibodies for Melissa, right? My antibodies are Melissa's antigens, and Melissa's antibodies are my antigens. So her antibodies are foreign to me, my antibodies are foreign to her. So it's all relative on who you're talking about. So when we're talking about blood transfusion, we're talking about the patient receiving the transfusion. So the patient receiving the transfusion has the antibodies, and the blood that's being given has the antigens. So if that makes sense, great. If it doesn't, don't worry about it. So we've got this Rh factor, and it comes in two flavors. It comes in positive and negative. And what does a positive and negative mean? It literally just means that it's there or it's not. So I'm going to draw the Rh factor as a little squiggle, orange squiggle. So if it's there, it's positive. If it's not there, it's negative. And it doesn't change based on what letter your blood type is. It's the same. So, and of course, I don't know the shape of these antigens or these antibodies. So I have no idea if they're squiggles. They could be. If they are, then that was a great choice on my part. An O can have antigens, or an O can have the Rh factor. And then you have O negative that doesn't have anything still. So now I have a positive and a negative. So if I have positive blood, regardless so don't think about the letters right now. If I have positive blood, who can donate to me? Can people with positive blood donate to me, or people with negative blood, or people with both? And the answer is people with both. So because I don't kill, my blood does not kill positive Rh factors. It does not kill Rh factors. It also doesn't care if the blood doesn't have Rh factors. It's not integral to the function of blood, whether or not it has Rh factors, just an identification marker. So it's kind of like whether or not someone has a passport. You know, if you're in your home country, who cares if you have a passport, right? But if you're in another country, then you kind of care if you have a passport. So people with positive blood can get blood from other positive people and negative people. But people with negative blood can only get blood from other negative people. Because if they get blood from a positive person, so they don't have the antigens, they're the antibodies, right? So if they get positive blood, those antigens, the Rh factor, is now a foreign substance in that person's body. So positive can donate, or can receive from positive and negative. Negative can only receive from negative. So knowing that, we've got A positive blood now. So who can A positive receive from? So it can receive from itself, and it can also receive from A negative, because again, it's A blood, and it doesn't matter if it has the Rh factor. And it can receive from O blood, and it can receive from O positive and O negative. So it can receive from A positive, A negative, and O positive, O negative. And A negative blood, who can A negative blood receive from? A negative can only receive from itself and from O negative. And then B positive is, like I said, it's kind of the same thing. So you can receive from yourself, from B positive, and you can also receive from B negative, and you can receive from O positive and O negative. And then B negative can receive from only B negative and only O negative. So it can receive from itself and O negative. Now AB positive, who can AB positive receive from? Well, it can receive from itself, AB positive, and it can also receive from AB negative, and it can receive from A positive and A negative, and it can receive from B positive and B negative, and from O positive and O negative. And if you've noticed, that's all of them. So AB positive is called the universal recipient. So if you have AB positive blood, you can receive from any blood. You can get a blood transfusion from a random person on the street and you won't die, which is pretty cool. I mean, unless they have diseases, don't AB positive is the universal recipient. Which is pretty cool. And then AB negative is not the same as AB positive. So AB negative can only receive from anyone with a negative. Because it can receive either A or B or O. It can receive A, B, or O, but it can only receive the negatives. So it's like half of a universal recipient. And then O positive can receive blood from itself and from O negative. And then O negative can only receive blood from O negative because it doesn't have anything, like if you put any antigen with O blood, it doesn't work. So O negative is only itself. So it's great that we know who we can receive blood to, but we also want to know who we can donate blood to. So my A positive person, who can they donate to? Well, they can donate to themselves, first of all. So they can donate to A blood. And that is, they can donate to A. They can also donate to AB. So just like AB could receive A positive blood, it's literally what we're doing. So A blood and AB. And then positive or negative. So they can receive blood, they can donate to AB positive, but not AB negative. They cannot donate to AB negative because now you're introducing a foreign antigen. So only A positive, only AB positive. But my A negative person can donate to A as well, and they can donate to AB, right? So they can donate to A and AB just the same as the A positive person, but they don't have any RH factor that we have to worry about. So they can donate to A positive and A negative, and AB positive and AB negative. So you can donate to both of them. And then my B positive person can donate to themselves, right? They can donate to B positive, and then they can donate to AB. But only the positive versions, just like the A. The A and the B blood, like just A and just B, are kind of the same thing. They're just different letters. So they have almost the same structure with regard to this graph and who they can donate to, who they can receive from. So I encourage you to make a graph like this, or make a chart like this, because it is so helpful. And especially, I wish I had more colors. If I had more colors, I'd be using different colors for every letter. But I don't, and that would take a really long time. So I would use different colors and try and make this yourself. So, or go back and rewind the video, make it with me. So we've got B donating to B plus, B positive donating to B positive, and AB positive. B negative, just like A negative, can donate to B, and it can donate to AB, but it can donate to both flavors. B positive, B negative, AB positive, and AB negative. And now, my AB positive blood, who can AB positive donate to? It has A antigens, or A antibodies, and B, and RH factor, which means that it can only donate to itself. So you can think of AB blood as kind of selfish. I'm not saying that people with AB blood are selfish. I'm saying your blood is selfish. A joke. But AB blood is selfish in that it will take anything, but it will only give to itself, to other people with AB positive. So AB negative is a little bit more forgiving. AB negative can donate to AB positive and AB negative. Still, AB doesn't like to share. Not at all. So then my O blood can only receive O, but it doesn't have A or B, which means it can give to A or B. it can give to both of them. So we are talking about O positive blood here, right? So thinking about just the letters, we can donate to A because there are no A antigens on here, right? And we can donate to B, and we can donate to AB, and we can donate to ourselves. And can we donate the positive or the negative version? We can only donate the positive. So we can donate to A positive and B positive, AB positive, and O positive. So now our O negative blood can donate to the same letters, right? Can donate to A and B and AB and O, but it doesn't have RH factor either, which means that it can donate to A positive and A negative, B positive and negative, AB positive and negative, and O positive and negative. And you are right in noticing that that's everyone. So O negative blood is called the universal donor. Oh, that's a B. I lied. Universal donor. So if a patient is in the hospital and they are like actively dying and you really need to give them a blood transfusion, but you don't, of course you always want to check the blood. I'm not saying don't check the blood, but there might be an occasion when you just don't, like this person's bleeding a lot and you need to give them something. You can give them O negative blood and they'll be fine. So O negative, anyone can receive O negative blood. I don't even know what blood type I am, but I could receive O negative blood and I wouldn't die. And then AB positive could receive anything. So it's not too bad once you break it down, but it's pretty cool. Yay, it's still recording. Okay. Alright. So I'm gonna erase this and we're going to talk about the more general aspects of what makes up our blood. flavors. And I like describing things as flavors because it makes me think of ice cream. No lie. So we have one type of formed element, and this is the one that you think of most when you think of blood and you think of what cell blood is. You think of erythrocytes. You think of erythrocytes. So erythrocytes are also called red blood cells, and the term erythro literally means red, and cyte means cell. So the word literally breaks down to mean a red cell. So it's not that big. It's not a big shocker to hear that. So erythrocytes, what is their main function? Their main function is to transport oxygen. And they do that, they transport oxygen so when they go to the lungs and they pick up oxygen, the oxygen kind of sticks to a little protein inside of the red blood cell, right? And that little protein is called hemoglobin. So the oxygen sticks to the hemoglobin, and if you, here I'll write a little word chart here for all of our words. So we know that erythro means red, and cyte means cell, and then hemo means blood. So it's a blood protein. It's a protein inside your red blood cell. So this hemoglobin has a little iron ion in it. And the iron is what the oxygen sticks to. So if someone has anemia, right, they're tired and they're lethargic, they don't really, they don't have energy, and it's because they don't have enough iron in their blood. And if you don't have enough iron in your blood, then not as many oxygen molecules stick to the hemoglobin. So you can have a bunch of red blood cells, but you don't have enough hemoglobin because you don't have enough iron that goes inside of the hemoglobin to stick to the oxygen. So you have a bunch of red blood cells, but they're not really very efficient. They're not carrying as much as they could, so you're tired because your body is like, I need more oxygen, but your red blood cells literally cannot carry more oxygen. So the treatment is to take iron pills, or take something. Eat meat. Meat is a really great way to absorb iron. Plant matter, not so much, because there's like chemicals inside the actual plant that hold on to the iron, so it's really hard to digest and absorb plant iron. But animal iron, you can digest that really easily. So our erythrocytes, they transport oxygen with hemoglobin, right? So, but there's a couple of terms that are kind of weird, right? So if I want to make a red blood cell, there's a specific term for making a red blood cell. And what is that term? It's called erythropoiesis. And this word is undoubtedly my favorite word in anatomy too. Erythropoiesis. And it literally means the process of making red blood cells. As you see erythro here, you've got your erythro, and so it's the process of making erythrocytes. And then, so what is going to stimulate erythropoiesis? It's a specific hormone, and we've talked about it a little bit in the endocrinology chapters. But the hormone that is going to stimulate erythropoiesis also starts with erythro, because we're talking about red blood cells specifically. So we're talking about erythropoiesis. Erythropoietin is the hormone that's going to stimulate erythropoiesis. And erythropoietin is released from where? It's released from your kidneys. Because all your blood goes through your kidneys, because that's where your blood gets cleaned out. So inside of your kidneys, there are little cells that have specific receptors for the amount of oxygen they're getting. Now, all your cells want oxygen, but not all of your cells complain about the lack of oxygen. These cells in the kidneys do. If they don't get enough oxygen, they complain, and they complain loudly to the kidneys. And so the kidney wants to keep them quiet, right? It wants to keep them happy. So the kidney releases erythropoietin to stimulate red blood cell synthesis, which is erythropoiesis, to make erythrocytes. So your kidneys release erythropoietin, that's step 1, and then erythropoietin stimulates erythrocytes, or erythropoiesis, and that's step 2, and then erythropoiesis results in erythrocytes, which is step 3. So kidneys release erythropoietin to stimulate erythropoiesis, which releases erythrocytes. It's a lot of the same word, but it's not, as long as you remember erythro, then you should be able to pick it out on a test. Just don't get erythropoiesis and erythropoietin confused. They're very similar, but they're very different. So it's kind of what we care about when we talk about red blood cells. They're exciting, but there's other more exciting things to come. So now we have the less, so this is it's actually not a cell, this formed element in the blood. It's not a cell, but it came from a cell. So it's tiny, and they are called platelets. So you have platelets running around your body. And what are platelets? They don't have organelles, they don't have nuclei, so they're not cells, but they're pieces of cells. So these platelets are actually pieces of a cell, of a specific cell with a specific name. They are pieces of megakaryocytes. Megakaryocytes are big, giant cells living in your red bone marrow, because all of these formed elements that we're talking about are made in your red bone marrow. That's where all of this is made from. So you have these gigantic cells called megakaryocytes, and they're huge, and they don't stop growing. They don't have a shutoff that tells them to stop growing, right? So they keep growing, but they keep adding cytoplasm, and they start to almost flake off on the outsides, and the flakes, or little pieces, are the platelets. So the platelets get absorbed into the capillaries in your red bone marrow, and they get sent out into the blood. And when they get sent out into the blood, they do a couple of specific functions that are really useful. So they are involved in something that we all know of, because we've all experienced it. You get a cut, what's the first thing that happens? Your blood clots. So your platelets are like the first line of defense in blood clotting. So your platelets are floating around, and they're doing their thing, and all of a sudden they see exposed tissue that's not supposed to be there because you got a cut, right? And the platelet sticks to that tissue, sticks to that cut, and then other platelets see it too, and they stick to those platelets, and they kind of pile up. So like if you think about sand, wind blowing sand onto like a step or something, and it'll like pile up on something, that's what's happening. You have your little platelets, and they just keep piling up on top of each other, and they form the first barrier, the first thing that's going to keep your blood inside. Because your body, the first thing that it thinks of when you're bleeding is, we have to keep as much of this blood inside as possible. So that's the first thing that it's going to focus on, is keeping all the blood inside. And then it's going to worry about all the rest of the clotting, making it look nice, making it perfect, making it last. But right now, all you care about is keeping as much blood in as possible. So they do blood clotting. They are involved in blood clotting, right? They're also involved in repairing the vessel. So they release. So if we want to stimulate the body to form, or stimulate a part of the body to form more cells and to increase metabolism, what function or what are we going to release? So we're going to release a growth factor. We're going to release a growth factor that targets the arterial or the vein walls, and that stimulates the cells inside of that blood vessel to multiply again. And it stimulates them to grow, and it stimulates the blood vessel to heal. So it's pretty cool. And then we also, so these platelets aren't just involved in the first step, they're also involved in the last step of repairing. So after you have plugged up the hole and you've got a scab and you're healing, you eventually want to get rid of that clot. So these platelets will actually release clot dissolving enzymes. So they release clot dissolving enzymes to get rid of the clot. So they're the first step and they're the last step. And they also will, they're like hold flag for, they patrol the whole body, right? There's tons of platelets and they're going through all parts of your body because they're in your blood, and they're super tiny so they can fit into any capillary. So they're patrolling, and all of a sudden they come across inflammation that's not supposed to be there. And they say, hold up, there's inflammation here, and they like raise their hand and they call all of the anti-inflammatories in. So a year and a half ago I injured my hand, right? And I bumped it, I hit it really hard to counter, and it was inflamed. But the inflammation got down into the joints of my hand, so it got like super far down. So what the doctor ended up prescribing was a procedure called a PRP. It's a platelet-rich plasma injection. So he drew my blood, and then he centrifuged the blood, which is the spinning process, right? And in the spinning process, all the red blood cells went to the bottom because they're heavy, and then all the platelets and the plasma went to the top. So they skimmed off the platelets and the plasma from my blood, and then they actually re-injected it back into my hand. Because if you put a bunch of platelets in an area, they're all going to raise their hand and they're going to call a ton of anti-inflammatories to come into that area, because your hand is not very vascular. It doesn't have a lot of blood vessels. It didn't, and my hand didn't have enough for what I needed it to do. I needed a lot of anti-inflammatories, and it just wasn't happening naturally. So the doctor put a ton of platelets in there to raise a really, really big alarm that says, hey, there's a ton of inflammation here, you gotta get over here quick. So all those anti-inflammatories came to my hand, and the inflammation went away, which was really cool. So the inflammation ended up getting better, but it wouldn't have gotten better by itself, but because of the platelets, it did. So I like platelets. I have a personal love of platelets. So they call anti-inflammatory agents that is a lot of stuff for not even a real cell, not even a whole cell, which is kind of crazy. So now we get to talk about the kind of the fun part of the formed elements, right? We're talking about our white blood cells, and the proper name for white blood cells is leukocytes. And we've got cyte again, right? Which means cell. But then we have leuko. And leuko means white. So we'll add that to our list over here. So they're literally named, the white blood cells and the red blood cells are literally named after their color. So we've got leukocytes, and leukocytes come in 2 different categories, right? So how many leukocytes do we have total? We have 5, right? So we have 5 leukocytes, and they're in 2 categories. And these categories have to do with what they look like under a microscope. So under a microscope, some of them look grainy, and some of them don't look grainy. So the ones that do look grainy, we call granulocytes. Because they look grainy. So we have granulocytes, and then we have agranulocytes. And if you see A in front of a word, it means without. So put that over here. So A means without. So literally it means with granules and without granules. That's it. So now, what types, so we'll start with our agranulocytes, right? Because we have less of them. We only have 2 agranulocytes. So our 2 agranulocytes are which ones? We've got, well, the first one is it's the really, really, really big one. And they're called monocytes. Or they're known as macrophages. And macrophages, I think macrophages describes them better because it actually describes what they do and how they perform their function, right? So macrophages go around, they patrol your blood, and they eat things. So when we're talking about cell eating, what is the term? The term is phagocytosis. So literally eating cells, and then the is means the process of. So it's the process of eating cells. It's literally what it is. So we've got the process of eating cells is our macrophage, our monocytes. And if you saw a slide of blood, right, and you were asked to point out and you saw a macrophage and you were asked to identify it, first of all, the first thing that you would look for is, does it have granules? And if it doesn't have granules, then you know it's an agranulocyte, right? And then if you're wondering if it's a macrophage, first look at the size. And if it's really, really huge, then it's a really, really good bet that it's a macrophage. Also, the nucleus in a macrophage kind of has like a little M shape almost. It's not perfect, but your macrophage kind of has a nucleus that looks like that, right? It's almost like an M missing the middle downstroke. So that's going to be your macrophage right there. And then you have another agranulocyte, and those are your lymphocytes. Your lymphocytes. So your lymphocytes they're smaller on a microscope, and they actually have a nucleus that takes up almost everything. So this is the nucleus right here, and on the slide it's stained purple. And then here's the nucleus of a lymphocyte. So if you're asked to identify, if you think it might be a lymphocyte, look for the absence or presence of granules, and then look to see how big the nucleus is. If you can only see a tiny, tiny, tiny bit of cytoplasm, it's a lymphocyte. And it doesn't have granules. So lymphocytes are your basic immune defense. When you think of a white blood cell, you're thinking of a lymphocyte. So they're your basic immune defense. They patrol everywhere and eat we've got our A granulocytes, and then we also have granulocytes. We have ones that have granules in them, or that look like they do under the microscope, right? So one of our granulocytes, we've got 3, they're called neutrophils. And neutrophils are specialized. So neutrophils have a very, very specialized function, and they go after a very specialized or a very specific thing. Sorry, I'm inhaling like pounds of chalk dust. Anyways, so your neutrophils go after one specific thing, and that specific thing is something that you really, really don't want in your blood. It's bacteria. Well, you don't want bacteria in anywhere. So, because your white blood cells don't just stay in your blood, right? They'll migrate out of your blood and into your tissues to fight for you. Because if you only fought in your blood, then any infection in your tissues would completely take over and you die. So your white blood cells can migrate out of the blood and into the tissues, which is cool. So our neutrophils kill bacteria, and on the and in a slide, you'll notice that neutrophils don't have gigantic nuclei, right? And they actually, their nuclei are kind of like kidney bean shaped, so they're like really, really, really small versions of the macrophage nuclei, but they have a few of them. So there's not usually just one, and then they have granules all over. So you've got your granulocyte, so it's a granulocyte, and if it has kidney bean shaped nuclei and there's a lot of plasma, then it's probably a neutrophil. And then, so after the neutrophils, we have another one, and this is also another word that I really like. It's an eosinophil. And eosinophils, what do they destroy? They destroy parasites. So we should be very, very grateful for our eosinophils because their work is wonderful. So they destroy parasites. They also go after allergens. They go after allergens, and they release inflammatory chemicals because inflammation is not always bad. And then they're like a cleanup crew. So they have like a day job and they have a night job, right? So their day job is actually cleaning up after the phagocytes. Because when something phagocytizes something, it will, and neutrophils phagocytize things too. I should put that in there. So when a neutrophil or a monocyte chews something up, right? It brings it in, it chews it up, and then it spits out a bunch of proteins and the leftovers. And you really don't want those proteins and leftovers floating around in your blood because your blood will get really, really thick. And if your blood is really thick, then your heart has a really hard time pumping it. And the longer your heart has a hard time pumping your blood, the more likely it is that you will develop some sort of heart defect or disease, and you could possibly die if your blood gets too thick. So your body is mainly concerned with keeping you alive. So we're going to keep ourselves alive by cleaning up all of they're called antigen-antibody complexes because they use antibodies to stick to foreign antigens. They take them in, they eat them up. So we'll learn more about that when we discuss the immunology chapter. So I'm just going to write cleanup crew right now. But they clean up after the phagocytes. And eosinophils underneath a microscope, they have fairly large nuclei. Sometimes there's 2, but they also are the only ones that will stain red. So if you see a red granulocyte, and these other ones will stain pink, the cytoplasm, but this cytoplasm will stain bright red. So if you see a bright red granulocyte, it's an eosinophil. So I'm actually going to write red here. So you got red, it's eosinophil. And then we have one more. We have basophils. So our basophils release two things that are really, really good to have. So one of their functions is to control blood flow. So they control blood flow, but how do they do that? So they control blood flow by releasing their two H's, two words with H that start with H, and they release histamine as the first one. So histamine is the first one, and why would we release histamine? Because histamine is a vasodilator. This piece of chalk is so tiny, my nails are scraping the board. So histamine is a vasodilator, and literally vaso means vessel. So you're literally talking about a vessel dilator. So we're going to put that over here. Vaso means vessel, as in blood vessel. So if you want to dilate your blood vessels, one of your options is to have your basophils release histamine. And that, if your blood pressure is too high, dilating your blood vessels will give your blood more room and the pressure will go down, which we'll also discuss later in the when we talk about blood in lecture. So, or in lab, probably do both. So it releases histamine, but there's another thing that it releases. It's not related to blood flow specifically, but like to blood pressure, but it does relate to blood in that it acts on blood, and it's called heparin. Heparin. It's called heparin, and heparin is it's a blood thinner. It's an anticoagulant to keep your blood from being too thick inside your blood vessels. Because again, like we said with the proteins, if your blood is too thick, your heart has too hard of a time pumping it, and you really don't want to make it hard on your heart. So heparin is an anticoagulant. And under a microscope, your basophils are the ones that look as if they don't even have a nucleus. There's so much nucleus that they literally just look like an entire nucleus themselves. So it'll literally be super, yes, that's supposed to be the nucleus. But there's tons of stuff in there. And it will look granulated, but you'll also mainly be able to tell it's a basophil because it's just packed full of nucleus, and that's basically what you can see. So those are the formed elements of the blood. I apologize again that this is not like a traditional SI with questions being asked. I got 8 minutes in the video, and then someone called me, so it is what it is. But I hope that this helps, and please watch this video by 2 p.m. on Wednesday, because I need Wednesday night to do my paperwork. So I apologize if that's inconvenient to everyone, but Wednesday night is the only time I have to do my paperwork for SI. So if you don't get your name in by Wednesday, I